Let's say we're asked to find the unit vector of this vector u in component form. So let's say vector u can be given by the component form 3, 4. So this tells us that vector u is equal to 3, 4. So we come along 3 and up 4, and that gives us this vector. Now the unit vector of this u is in the same direction, but it's of length only 1. So we want to find this unit vector. Now what we can do is we can start off by finding the length of vector u. So the length of vector u is going to be 3 squared plus the 4 squared. We take the square root of it, and that's going to give us 9 plus 16, which is 25. The root of 25 is 5. So the length of this vector is 5. So we want the length of the unit vector has to be a fifth of this. So it means that we're going to have to go along a fifth in this direction and a fifth of it in this direction. So that means that we can say that the unit vector, now the unit vector is usually written as the little hat above it like that, as opposed to the line, and this tells us it's a unit vector. So it's got magnitude 1. So it's going to be 3 divided by the 5 and 4 divided by the 5. So this here is the unit vector of the vector u. So that's this one here. So you can see that that does actually work, because this vector should have a length of 1. So the length of this vector is going to be 3 upon 5 squared plus 4 upon 5 squared, and it'll be the square root. So that is equal to 9 upon 25 plus 16 upon 25, which equals 25 upon 25, which does equal a value of 1. So let's look at some other examples. So let's say we're asked to find the unit vector of the vector a. And let's say the vector a is given in component form 2 minus 3. So we go along 2 and we go down 3. So this is vector a. So we're looking for a hat, which is the unit vector of vector a. So what we have to do is find the length of vector a. So the magnitude of vector a is going to equal the 2 squared plus 3 squared root. So that's going to be equal to 4 plus 9 root. So that's equal to the root of 13. So the length is going to be root of 13. So it means that the unit vector a is going to equal 2 upon root 13 minus 3 upon root 13. So this is the unit vector of vector a. So it's a vector of length 1 that is in the same direction as a, and we call it a hat. And again, you can multiply these out. You can square this and square that, take the square root, and you'll get a value of 1. So let's move on to something else. Let's look at an example of using the position vectors. Let's say we've got a point P, which is minus 3, 5, and we've got a point Q, which is 9, 0. And we're asked to find the vector PQ. Now we've seen from the previous videos that we've done that we can find the vector PQ. That's going to be equal to the vector Q, which is the position vector, minus the position vector P. So that should be equal, in component form, we're going to have the vector, we're going to have 9, 0 minus the P, which is minus 3, 5. So that's going to equal 9 minus minus 3, which is 12, and 0 minus 5, which is minus 5. So it means that the vector PQ is equal to 12 minus 5. So this is the answer here. So let's go ahead and we'll draw that out and see why that's the case. So let's say we've got the position vector P, which is given by minus 3, 5. So we just take a point here, and we're going along minus 3 and up 5, so it's roughly in this direction here. So this is the origin, and this is the point P, which is minus 3 and up 5. And this vector here is going to be the position vector, small p. And let's take the next one, is point Q. So the point Q is along 9, up 0. So we come along 9, and we go up 0. So that's going to take us to the point Q. So this length here is going to be the position vector, small q. So now what we want to do is find the vector PQ. So we want to go from point P to point Q. So we'll go from this point to this point here. So this is going to be our vector PQ, which is what we're looking for. So that's going to be equal to minus P plus Q, or equivalently we can say it's going to be Q minus P. But Q minus P is simply going to be equal to the 9, 0 minus the minus 3, 5, and that's going to give us the value over 12 minus 5. And you can see here that this vector here is going to be coming along a value of 12, and we're going to be going down a value of minus 5, and that will give us this vector PQ. So thank you for listening. I'll get you on the next video. Goodbye.